Welcome everyone. I'm Tolani Goki, a lab assistant at Force Discovery Center, ReVEL facility, a facility that is situated at the University of Hare. ReVEL is basically a first of its kind remote and a virtual education lab. UFH ReVEL was established in collaboration with LabsLand, one of our international partners. ReVEL is mainly divided into two components. The first one is teaching and learning coding robotics online using a specific programming language, Aurdino in our instance. It also allows users to access various international labs remotely. This is an integral part of coding the robots and the Aurdino board, and there are only 3 in the world, which is this one in South Africa and the other 2 in Colombia and Spain. Here's the Aurdino board. For demonstration purposes, I'm going to show you how this works so that you may access a real-life lab using the use of the internet, through the use of the internet. As I have mentioned, for you to be able to operate the Aurdino robot, you must first be connected to the internet, where you will have to open the browser, then type in the URL. This one will take you straight to the homepage of LabsLand, where you will be able to operate real laboratories through the use of the internet. Now let's remember, for the first time users, they are required to first sign up for free. But unfortunately, since I'm already a user, I will proceed by logging in. Let's log in. Now this is the UFH portal. This is the homepage of the UFH portal, the University of Hare. Let's access the labs that it contains. This is the ReVEL group where we have grouped the labs accordingly. Now we have quite a number of them, namely we have Aurdino robot code, we have Aurdino robot visuals, we have Aurdino board code, we have Aurdino board visual. But for the sake of a demonstration today, we'll be focusing on Aurdino robot visual. Now the Aurdino robot visual is simply made up of Aurdino blocks. Let's access it so we can clarify it further. Now this section is mainly a robot visual IDE, which enables one to drag and drop the operators on this left. Now we have quite a number of them, the operators functions, we have inputs, we have time, we have comms, we have LEDs, we have buttons, we have motors, proximity, line sensor, the loops, etc. Now for you to take the operator on the left, you just drag and then you drop it on the right. Now we'll have to just create a program where we have to demonstrate on how to make use of the operators on the left. Let's write a code where the robot avoids to hit any object in front of it. Now for us to be able to do that, we drag and drop the loop function, and then also we insert the proximity sensor. The proximity sensor is going to enable us to detect any object in front of the robot. Now, once the robot is moving, let's insert first the speed that is going to move with. The speed, it has to be 100, let's say 100 in this instance. Now we also inserted the same speed on the left tire. Let's take it 100 as well on this side. Okay. Thereafter, we tell the robot the conditions that it must execute. Now, if the robot detects any object in front of it, or let's say on the right, so therefore what must happen? Now, let's tell the robot the conditions. Now, using the proximity. Let's say it detects an object on the left. So now to avoid it on the left, it must move to the right. how long should it detect? Let's say at least 6 centimeters away from the robot. For us to tell the robot to move on the left, we have to switch off. To move on the right, we have to switch off the right. Now let's switch off the right. So our right tire will be on a speed of 0. And then our left tire is going to be on the speed of 100. Let's take, let me say 100 on the side. So now it's going to turn on the right after executing the conditions. After executing the conditions, it must wait at least 1000 milliseconds. So which is equivalent to what? To 1 second. Now let's verify our program thereafter. Therefore, the program, once it says it's successfully verified and compiled, you upload it. Now let's wait and see what happens when we upload it to the robot. Once you are in this interface, you then upload to the robot that you choose to execute the program. You can choose any circuit out of the 3 countries that have this equipment or facility in the world. But for our demonstration purposes, I think let's choose Mount Melo, which is situated here in the University of Hare. Then you can see that this is hosted at the University of Hare. And then from this part, we can tell our robot to execute the code that we have programmed on our interface. Now let's wait while it executes the code. Let's wait. Let us see, it's going to detect any object in front of it and then avoids to hit it. Successfully avoids to hit an object. Let us see what happens there. It also avoids to hit an object again, and then it just turns. Now, based on this, I think we can see that you are able, through our facility, you are able to access real-life labs with the use of the internet. Let us see, it's going to hit the wall. Yeah, it doesn't hit the wall again. Now, on the top left, you can see that it is a timer. I think you are given only 2 minutes to execute the code, the program to execute the code. And now it's counting down. I think we are left with less than 30 seconds. Then once it reaches 0, I think it's going to switch off the robot, and then it waits for another user to use it thereafter. It's less than 10 seconds now. So the robot is successfully avoiding to hit an object.